Hello there, Mr. Chan for Algebra 1. About to start topic 8 review, 8-1 through 8-3. We didn't do the whole chapter. Grab your worksheets and turn to page 351 and let's get started here. We have some vocabulary to fill out here. We are going to do number 2, 3, and 5, but not number 4 or 6 for the vocabulary. All right, here we go. The graph of a quadratic function is a blank. In this case, it's definitely a parabola. Let's jot that down. Number 3, the function f of x equals x squared is called the quadratic parent function. Awesome. Number 5, the blank is f of x equals ax squared plus bx plus c. This is the standard form of a quadratic function. All right, that takes care of the vocabulary. Let's move on to 8-1, key features of a quadratic functions. We have a quick review about a parabola. A parabola has a vertex, in this case for the parent graph ax squared. Remember, a parabola is a U-shaped graph. Its vertex, meaning either the lowest or the highest point, depending on which way it's opening, is called the vertex. There's an imaginary line that splits the parabola in half, called the Axis of Symmetry. And it has symmetry, literally splits it in half. And it tells you which way it opens. If your A value, the leading coefficient there, is positive, it opens upward. If it's negative, it opens downward. So when it opens upward, it has a minimum, because its lowest point's right there. When it opens upside down, it has a maximum. So we have the lowest point and the highest point, depending on which way it's opening, yeah? And that's based off of the minimum and the maximum right there for the vertex. Here's an example of one that's graphed. Let's try number 7 together. Compare the graph of each function with the graph of f of x equals x squared. X squared, I kind of started off doing it over here in the upper right-hand corner there, has 5 points you should be aware of. They are based off of your domain of -2, -1, 0, 1, and 2. When you plug those numbers into x squared, you will get 4, 1, 0, 1, and 4. Those points correspond to this graph right here. Let me zoom in a little bit so you can see a little better. -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Those are the 5 major points you should be aware of for the quadratic function that graphs a parabola. It's a U-shaped graph. Okay, so it's kind of interesting. For number 7, our coefficient 1.5 is the A value. 1.5 is definitely bigger than 1, right? 1 is what's in front of x squared. What will happen to this graph? It will stretch it. This is called a vertical stretch when you graph it. It's skinnier, narrower, they might say, because 1.5 is bigger than 1. Take a look at number 8. Its A value is -9. A couple things going on here. Not only is it negative, but 9 is very, 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 very big. So it's also a vertical stretch. And because of the negative sign, it's upside down. Remember over here on the left here, when it's upside down, it's reflected. Let me show you those two scenarios using a little quick graphing calculator. Here we go. We have, of course, we have x squared and we have 1.5x squared and we have -9x squared. Let me zoom in a little bit so you can see this. It's kind of hard to see. The original parent function is in red. The blue one is hard to compare, but it's above the red one. The blue one is for number 7. It's been stretched upward further. It's higher up. Whereas number 8, the negative flips it upside down to 9, and it's much, 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 much more extreme. Let me zoom in a little bit better so you can see that relationship there. So right here we have the red, which is the parent graph. The blue is a little higher by 50% more, but the green one that's upside down, it's 900% stretched this way. Does that make sense? If you look at the left edge right there, okay? It's one way of looking at it. So that, ladies and gentlemen, takes care of 8-1. It's based off of the A value. Next section, that was fast. 8-2. We are looking at a quadratic in something called the vertex form. And the formula for that is right here. F of x equals to a times x minus h squared plus k. H and k in that particular form will give you something called the vertex. The axis of symmetry's formula is x equals h. So with that in mind, we're going to go ahead and uncover a lot of this information based off of those formulas right there. We have an example right here. That's a great way of just getting started and see how it relates to the graph. They mentioned that, in this case, the vertex is at -1, -1. Now remember, compare it to this formula, a times x minus h squared plus k. This should be very familiar because we did the absolute value function, the v function, last semester. We're just applying it to the U-shaped graph, the parabola, this semester, okay? It's virtually the same as the other one. All right, let's take a look at number 11. Graph the functions below. How are the graphs alike and how are the graphs different from one another? Take a look at the actual problems themselves. They're both negative, which is interesting. They're upside down. So how are they alike? There's a vertical reflection, so it opens downward. Both of those, because of the negative. Great. What's another thing? They both have the same vertex. HK. Remember the formula. Their H's and K's are the same. In this case, the vertex is at 3, 2. H is always backwards, okay? That's awesome. How are they different from one another is the other question. They're different because of one value, their a value. F of x's a value is stretched more. In fact, it's 500% versus the g of x is 200%. Does that make sense? So it's stretched more, it means it's narrower. That takes care of number 11. Yay. Number 12. They're looking for the vertex and axis of symmetry. Vertex is at hk. Axis of symmetry is x equals h as a formula. So let's do number 12 here on the right. The vertex is staring at us right now. H is right there. And you got to think of minus h. So h is negative 8. And k for number 12 is positive 1. So let's write that down for the vertex. The axis of symmetry's formula is x equals h, negative 8, and that's it. Very easy. How about number 13? Number 13's vertex. H is, got to be careful here, positive 5 this time around. I think backwards. And k is negative 2. Let's put those down in there. And that takes care of number 13, the vertex. How about the axis of symmetry, the vertical line that splits the parabola in half? X equals to the h value, in this case is 5. Yay. Wow, that seemed pretty fast. Any questions about section 8-2? Let me know. Let's move on to the last section of chapter 8. Chapter 8-3. Ooh, standard form. Now, we're still going to graph parabolas, but the parabola is in this form, ax squared plus bx plus c. There are a couple of formulas that will give you your axis of symmetry, your y-intercept, and your vertex, okay? I like to look for the y-intercept first, which is the c value. That tells you where it crosses the y-axis. When it crosses the y-axis, x equals 0. Now think about that for a second. When you put in a 0 here and a 0 there, everything disappears except for the c value. Make sense? For the y-intercept, that's why we get that. Axis of symmetry, there's a formula. X equals negative b over 2a is your axis of symmetry formula, okay? Vertex is last. To get the vertex, you got to use the axis of symmetry value and then plug it into the equation to get the y value. Those are your steps. Those are the 3 things involved. There's an example of that right here, really nice one right here that shows you all those steps. You can take a look at that when you get a chance. But I'm going to jump to number 15 and 17, 18 and do those problems. And then we can call it a day. This is a short chapter. All right, number 15. Identify the y-intercept, axis of symmetry, and vertex of the graph of each function. And I'm actually going to skip number 16 because it's ugly. Ugh. A lot of fractions there. All right, here we go. Here's the process to finding those parts based off of the quadratic in standard form. Ready? We're talking about ax squared plus bx plus c. Okay. Here's number 15. Look for the y-intercept first. The y-intercept is the c value. The c value in this case is 5. That's where it crosses the y-axis, this parabola. Great. And they want us to graph this eventually anyway, so I'll do that over here off to the right. Number 15. Second step, find the axis of symmetry. There's a formula, x equals negative b over 2a. B, in this case, is 4. a is the number in front of x squared. That's -1. Okay, you guys see that negative sign? That's -1. -4 over 2 times -1 is -4 over -2. -4 over -2 is +2. Ladies and gentlemen, that is your axis of symmetry. Okay. So go to 2 on the graph and put a vertical line through there. That's your AOS. And my y-intercept is 5. Got to graph that. 1, 2, 3, 4, 5. Put a dot there. Great. Now, somewhere on the axis of symmetry is my vertex. That's last. So let's put that in. I know half the vertex already, 2. The answer we just got a moment ago. We just have to plug that into the equation, -x squared plus 4x plus 5. So let's do that. So we are literally doing g of 2. Sorry. Plus 4x plus 5. Let's plug the number 2 into there. See what happens. Now this is function notation. This is why I don't think it's g times 2. So let's clean that up. 2 squared is 4. Nothing to do with the negative sign. -4 plus 8 is 4. 4 plus 5 is 9. Oh my gosh. The vertex is 2, 9. Need a little more space up there. So 6, 7, 8, 9. Way up there. Wow. Ladies and gentlemen, there's my vertex, 9, 2, 9. My y-intercept is 5. So this is the vertex right there. It opens upside down. So half the parabola looks like this, yeah? And the other half is on the other side. So if we kind of eyeball the y-intercept and put a dot right here, I could just connect the other half of the parabola. And there it is, yay! My upside down parabola. Very nice. Okay, let's jump to number 17. When given a function in standard form, how can you determine if the parabola has a minimum or a maximum? Now this kind of goes back to originally the previous section, sorry, 2 sections ago, about the a value. Minimum means it opens up. When it opens up, the a value is positive. Maximum is when the parabola is opening downward, meaning this point that has the maximum way up there. This is where the a value is negative. So that's how you know that situation, okay? Yay. You guys ready for number 18? Last one. We're going to graph that function using the parts that we need here. Okay. Step 1. Find the y-intercept. This is number 18, by the way. The y-intercept is the constant by itself. In this case, is 5. Awesome. Axis of symmetry is next. Form is -b over 2a. B is 12. Yeah. A is -3. So let's put those numbers in, right? Let's do that. B is 12 and A is -3. Let's see what we get when we clean this up. -12 over -6 equals, oh, +2 again. That's kind of weird. All right, so that's your, I'm just using this information so I can graph it in a moment. Vertex. We know half the vertex already, 2, blank. Let's plug in 2 into the function. Here we go. Let's do the math here. F of 2 equals -3 times 2 squared plus 12 times 2 plus 5. We'll plug in the number 2. do the math here. 2 squared is 4. Negative 12 plus 24 plus 5. 12 plus 5. Oh my gosh, 17. That's a crazy y value. But we're done. That's your vertex. So this particular graph, just like the last one, also opens upside down because of the negative a value. So we need to just eyeball this a little bit. So my vertex is at 217. What the heck? 1, 2, and let's just call it 5, 10, 15, 16, 17. Oh my gosh. So there's my vertex right here. Axis of symmetry is 2. The y-intercept is 5. This is a very skinny feller. Connect the dots from the vertex to the y-intercept. And kind of eyeball that half. And we're done. Yay, there it is, ladies and gentlemen. We are finished with 8.1 through 8.3. Thank you very much. Let me know if you have any questions. I'll talk to you next time. Have a good day. Bye-bye.